Welcome to my video tutorials. This tutorial is dedicated to the next very useful and basic law in circuit analyzing and practice. It's called Ohm's law. Ohm's law defines the relationship between voltage, current and resistance in electric circuit. The current is directly proportional to the voltage and inversely proportional to the resistance. What I mean? One of the best methods to remember the Ohm's law is this triangle on which we see these three physical quantities: voltage, current, and resistance. This triangle is very useful because if we want to find the current, so numerator will be the voltage and denominator will be resistance. In case if you want to find the voltage, both physical quantities, current and resistance, will be in numerator. Means voltage is current times resistance. When we consider any branch in electric circuit and look on resistor R, how to measure the voltage, we need to connect the voltmeter between 2 points. Current does not go to the branch because voltmeter has unlimited resistance, so current will go only through the resistor R. Respectively, how to find the current if you know the voltage and resistance. For example, voltage will be 10 volts and resistance will be 10 ohms. Taking into consideration Ohm's law, the current is voltage divided by resistance. 10 volts divided by 10 ohms is 1 amp. Another interesting situation will be the branch or the loop in which we see the resistor R, voltage source E, and current source I. So how we can find the current in this case? We have the voltage between 2 points, between node number 1 and node number 2. Then we have the voltage source, which is included in this loop, and resistance, and current source. Depending on the direction of voltage source and current source, respectively, we will see the sign before the value of voltage and current source, respectively. Voltage between 2 points 1 and 2 can be found like the difference between the potential in node number 1 minus potential in node number 2. So in current example, taking into consideration the direction of all voltage sources and voltage between 2 points and the resistance, we will have the following answer for the current I. In the next example, I'd like to explain you how the last equation will be changed accordingly to the direction of voltage source and current source. In the previous example, the direction of voltage source was from the node number 1 to node number 2, and respectively the same direction of current source. So these two sources in the equation will be with plus sign. In the last example, we have the same voltage. Voltage 1, 2 is Phi1 minus Phi2, but direction of voltage source is from the node number 2 to node number 1, respectively the same direction of current source from the node number 2 to node number 1. So these two values in the last equation will be with minus sign. So just pay the attention to the direction of current I in our two examples, the direction from node number 1 to node number 2. And respectively, if the same direction have two sources, voltage source and current source, they will be with plus sign. Or if these two sources will be in the opposite direction, so their values will be with minus sign in the final equation. And the last very useful example in current tutorial. I'd like to explain you how to find current in two branches when you know the current which goes to the node before distribution between two branches. Means when we have input current I, which go to the node number 1 and then divided by two currents on this node I1 and I2. How we can find the current number 1 and the current number 2 when we know the current I and resistance R1 and R2. We just need to write down I1 is I, input current, times R2 and divided by the sum of R1 and R2. Respectively, we will have the similar equation for the current number 2. I2 is I times R1 divided by R1 plus R2. It's very easy, so please use it.